7.1. Let's get chapter 7 started. Ratios and proportions. So when you're doing this, if you're not sure where to start, make sure you come back to this. Right after the proportion, make sure you label cross multiply, write your answer with correct units. So first you have to have units to have them though. When we're talking about the cross product property, a lot of times people in elementary classes talk about the butterfly effect, or that's actually a movie. But really what we are doing when you're looking at this is we are solving the equation. Because whenever you have the equal sign, remember, when you have division, in your brain, you can think, oh, how can I move over division, or how can I cancel out division? Well, the opposite of multiplying or opposite of dividing would be multiply. So if I multiply this side by b, I would have to multiply this side by b. Those two would cancel. Same thing here with this divide by d. If I divide this side by d, I would have to multiply this side by d. And then those two cancel, leaving you with this, that BC times AD. So that's really why it works, is because we're already using the properties that we already use in our brain. Now, a lot of times we will say, make sure to have a fraction equal fraction. That shouldn't say problem 4, it should say problem 1. Make sure you have a fraction equal fraction. And then in your brain, because of this equal sign means you want to do the opposite that's shown. So opposite divide by 4 would be multiply this side by 4 equals the opposite of divide by x would be multiplying this side by x. Now this becomes 24 is equal to 5x. I want you to leave your answer in fraction format. So to get rid of this multiplication here, the opposite of multiplying would be dividing. So x in this case would be 24 fifths. I want you to pause the video and do b right now by yourself. Pause and do b. So you should have gotten x is equal to 40 over 3. Again, I want you to leave it as a fraction like this. So I multiplied this x over, I multiplied this 8 over, that's where the 40 comes from. What happens here? Well, still the same thing. You're getting rid of this division, so you multiply this side by 3. But when you multiply this side by 3, you have to make sure that you're multiplying that whole thing by 3, not just one term. And then you multiply, getting rid of this division, you multiply this side by 9. When I solve this, I first distribute my 3, and then I start solving for y. So I'm going to move this positive 3 over. So the opposite of a positive 3 would be subtracting 3 over to the other side. So now I have 12y is equal to 12, not y, equal to 6y. Divide both sides by 6. So y would be equal to 2. I want you to pause the video and try to do d by yourself. So this whole 3 gets multiplied by everything, so that becomes 12n. This becomes plus 3. Multiplying my 2 times n, 2n times 7, you get 14. So I can subtract this 12 over and then divide by 2, so your answer should be 3/2. Now, these next set of questions are asking, are these two equivalent? Well, remember, we can check this. So if I were to move the multiplications over, if I were to move my multiplication, this would be the same thing as AD is equal to BC. Once we're multiplying, doesn't matter if you had DA or CB. So now I'm going to check to see if this is the same thing. This would be BC is equal to AD. Well, because I'm still multiplying the same thing and it's still equal, these two would be the same. They are equivalent, equal to each other. I want you to pause the video and try to do 2 and 3. Now the second one, you might have gotten the same thing. So even though that second fraction is written a little bit differently, it doesn't matter. You still end up with the same thing, AD. Now this one's a little bit more confusing. How can we check to see if it's the same? Well, I can simplify these two equations. So I'm going to distribute that D. So I have AD, then I'm just looking at this second part because I want to see if it's the same as this. So now I have AD plus BD is equal to BC plus BD. Now I want to see if these are the same. So I'm going to subtract BD on both sides. And again, that's the same thing as if this was 3 times 2. Well, if I subtract 3 times 2 on this side, subtract it from this side, I'm left with AD is equal to BC, which was our original one. So yes, these are the same. So for these next set of questions, we aren't solving anything. We are trying to just set up the proportion using this as a guideline. So it's kind of rewriting things like up here. So it's telling you x over y. So in this case, I'm going to look at x should be across from y. So now that's on the same fraction. That means now x and 6 should be across from each other. Now 6 should be on the top here, looking at this, and then 7 should be on the bottom here because they were on the same fraction. So looking at this fraction, again, the x and y are across from each other. They were on the same fraction, or else x and 6 are on the same line. Same thing here. Y and 7 are either on the same fraction right here, or else they are across from each other. So I want you to try to pause the video and try to do this one. Try to set up the proportion. And you should have got that 6 and x were on a fraction. That means across from the 6, the other fraction should be 7 over y. Again, you could have looked at this to help you. And if 6 was on top and it was already flip-flopped, so it was basically flip-flopping this equation here. Now we get to this adding, kind of like this up here. So we already proved that this was correct. So in this case, it would took the bottom and add it to the top, like this. So if I want to make sure that's correct, that means I'm going to take the bottom and add it to the top. We used this fraction. This was the fraction for this because it was y over 7. So now we have to do the same idea, but with our x. So our x was x over 6. But to make it these two equivalent, that means I have to add 6 to the top. So it's taking that same idea here. The b was on the bottom, we added to the top. Here the d was on bottom, we add that to the top. So it's completing that ratio. So now you heard me say ratio for that last problem. So when we're talking about ratio, it's comparing the simplified version of a length. So we can either represent a ratio as a fraction with a colon or by the word 2 in between. So it's saying a model car, right here, we're going to be using ratios. The car in actual feet is 9 feet and the model is 6 inches. What is the ratio of length from car to the model? So again, length of the car number should be first, the model. Now, when you're doing this, you have to make sure you have the same units. Feet and inches are not the same units. However, I know that 1 foot is equal to 12 inches. So I'm going to change 9 feet into inches. So 9 feet is the same thing as 108 inches. So we're comparing 108 to, if I use it as a fraction, in this case, 6 inches. You want to see if you can simplify that fraction. And in this case, I know you can. This is the same thing as 18 to 1. If I were to write it as a colon, that ratio would be 18 to 1 or 18 to 1. It's saying that 1 inch of the model is real life 18 inches in real life. That's what that's saying. So I want you to pause the video and try to do the second one by yourself, knowing that you will need to change this to inches. Change this to inches first and then try to simplify. Now, this is where you have to be careful. It's saying model to the actual. So the model number has to go first. So in this case, my model number was 60. So this could be 60 over 15,000. And if you were to simplify that, that's 1 over 250 or 1 250 or 1 to 250. So again, it's saying that 1 inch represents 250 inches in real life. That's actually all we're going to do for right now. We are going to be doing the rest of these problems in class together. So have a great, grand, wonderful day.